first channel. In today's video, I will be taking you through a series, and that is the nomenclature of organic compounds. So we are starting with the Iupac nomenclature of the simplest hydrocarbon family, and that is the alkane family. The alkane family is regarded as a root family for all organic compounds. So every organic compound is traceable to the root of the alkanes. Okay, so we are beginning with the nomenclature of the alkane family, and when we are done, we'll look at the nomenclature of the alkenes and the alkynes. I'm going to handle the two families at the same time because they operate using the same principle. When I'm done with the alkenes and alkynes, we shall look at the alkanols and the alkanoic acids. When I am done with the alkanols and the alkanoic acids, we'll now bring up the alkanals and the alkanones. Now, videos are uploaded in this channel based on requests from people, from our viewers, from our subscribers. So, you as a student or a teacher that's out there, this video is designed to simplify things for you to make, because there is no way you write any exam, say GCE, WAEC, or whatever exam you want to write, and it is a subject is chemistry, and you do not see anything on Iupac nomenclature. So it is a must. It is a must that you learn how to name organic compounds. Okay, so without wasting much of your time, let us go to the board and demystify the process. Alright, welcome back. Now we are going to look at the alkane, the nomenclature of the alkane family. Now remember that alkanes are a group of saturated organic compounds or hydrocarbons, and they have no double bond. They have no double bond. And being a hydrocarbon, that means they consist of carbon and hydrogen. Now, having this in the back of your mind, it will enable you to know when a structure is drawn, for you to know the family or the homologous series from where the compound is coming from. So we're going to look at some examples, but before I start, there are things that I will let you know before you start naming your alkanes. There are things you need to know. We call them rules. So now these rules are very, very prerequisite to naming the alkane family. Okay, first of all, we need to look at three main parts of the Iupac nomenclature, the three main parts that makes up the Iupac nomenclature system. Now the first part is called the prefix. So I'm going to be taking time to teach you how to arrange your prefixes, how to go about the prefixes. Now, what is the prefix? As the word implies, prefix, it comes before the root word. Okay, it comes before the root word. We'll be back shortly. Alright, welcome back. Prefixes. Prefixes come before the root word. And in the course of this lesson, I will be taking time to explain how to use your prefixes. What are prefixes? They are simply substituent groups. Substituent groups. What are substituent groups? They are atoms or group of atoms which take the place of hydrogen atom in a given hydrocarbon chain. So a substituent group can be a halogen. A substituent group can be any atom that is more electronegative than hydrogen. A substituent group can even be a radical. It can be a group that is more electronegative than hydrogen. That's why it is called substituent group. So we're going to look at some common substituent groups that are normally or commonly used in Iupac nomenclature. Okay? Now let us see some of them. Now we have the alkyl group. The alkyl group. The alkyl group here can function as a substituent group. An alkyl group can function as a substituent group. Now, what's an alkyl group? An alkyl group is a group of compounds derived or obtained from the alkanes by the elimination of one hydrogen atom For example, if we have CH4 to be methane, once I remove one hydrogen atom, it becomes CH3. Once I remove one hydrogen atom, it becomes CH3. Now CH4 here is pronounced methane. But when I remove one hydrogen atom, it turns to methyl. Methyl. So from methane, it becomes methyl. So in the same way, C2H6, which is ethane, we change to C2H5 when I remove one hydrogen atom. And then the name changes from ethane to ethyl. From ethane to what? Ethyl. Okay, so an alkyl group such as methyl, ethyl, propyl can function as a substituent group in a given hydrocarbon chain. Okay, so we have seen that methyl group can be a substituent group. So we are talking about substituent groups. Substituent groups. Okay? So methyl CH3, C2H5, that is ethyl. Ethyl. Okay? Then C3H7, which is obtained from propane, now becomes C3H8, sorry, C3H7, now becomes propyl. Okay? Propyl. Then butane, when you remove one hydrogen atom, becomes butyl, and so on and so forth. Then halogens can also function as substituent groups. For example, chlorine, bromine, iodine. Then when you see them on the hydrocarbon chain, their name is pronounced as, when they function as substituent groups, like the chlorine becomes chloro, the bromine becomes bromo, then the iodine becomes iodo, fluorine becomes fluoro, and so on and so forth. So halogens can function as substituent groups. Now we also have the hydroxyl group, we have the nitro group. So any group that functions in the place, in the state of hydrogen, is considered a substituent group. So now that we have seen some common substituent groups that we normally use in the Iupac nomenclature of hydrocarbons. Now let us look at the rules to using the substituent groups. What are the rules? Number one, when there is a substituent group on a given hydrocarbon chain, numbering of the chain is very, very important, very, very expedient. It is expedient, you number your hydrocarbon skeleton, so you'll be able to dictate the position of that substituent group on the chain. Let us take, for example, if I have a chain containing these carbon atoms, and as usual, surrounding the hydrogen, and there is a presence of a halogen like chlorine on the chain. From what I said, now this chlorine here is now taking the place of hydrogen. That is why we call it a substituent group. That means it has substituted hydrogen in the hydrocarbon chain. Now for us to know the position of this chlorine on the hydrocarbon skeleton, we need to do what? Number the chain. And numbering of the chain can either start from your left side or from your right side, because we have two ends to the chain. So this is end 1 and this is end 2. So I can start from end 1, but before you choose where to start from, please check the proximity or the distance of the ends to where you have that substituent group. The closer end is where your numbering should start from. Now if I start from here, I have 1, 2, 3. That means chlorine will be in in position number 3. If I start from here 1, 2, that means chlorine will be in position number 2. The rule says the shorter distance is the one that you will consider. Okay? So to number the chain, I will begin with this. This is number 1, this is number 2, this is number 3, and this is number 4. So the chain has been numbered in the right, from the right side. Now, if you start from this side, you're going to have chlorine in position number 3, and that is wrong. That's very wrong. But if you start from here, chlorine is going to be in position number 2. So now, how do we present our substituent group now? We first of all call the number which signifies the position on the chain, which is 2. 2 chloro. 2 chloro. So it goes this way, 2 chloro. That's how it's done. So if it is bromine that is in the same position, you say 2 bromo. If it is metal that is in the same position, you say 2 metal, 2 propyl. So it depends on the position of that substituent group. That is rule number 1. Okay, so numbering of your chain must start from the end that's closer to where you have the substituent group. Take it down. That's rule number 1. Now, rule number 2 to using prefixes. Rule number 2 to using prefixes. There are sometimes you might have more than one substituent group, the same substituent group on a given hydrocarbon chain. For example, I might have more than one chlorine atom in a hydrocarbon chain. I might have 2, 3, 4, and so on and so forth. So when you have the same substituent group, different substituent groups, the same substituent group on the same hydrocarbon chain, how do you go about your naming? How do you name your prefix? Now, I'm still using the same structure. Now, supposing I have another chlorine atom here, right? So we now have the presence of 2 chlorine atoms on the same hydrocarbon chain. Now, in this case, what we normally do is we take their position, the position of the 2 groups, that is the 2 substituent groups, we take their position, they are in position 2, 3. Position 2, 3. See, I collected the position first before writing the name of the substituent group. So 2, 3, then we use the word di, tri, tetra, penta, and so on and so on to show the frequency or the number of times that group or that substituent group occurred on the chain. Okay? So 2, 3 dichloro. So when you say dichloro, it simply means that the chlorine occurred 2 times. So it's going to be 2, 3 dichloro. 2, 3 dichloro. Now, you might even have chlorine in another position. Let me say position number 1. Position number 1. So, in this case, it's going to be 1, 2, 3, trichloro. That's it. So, when you have more than one substituent group and they are the same homogeneous substituent groups on the same hydrocarbon chain. So this is the rule for the naming. So let us go to rule number 3. Rule number 3. So before I introduce the rule number 3, just hold on for a while. I'll be back shortly. Welcome back. Now there are cases that you might have different substituent groups on the same hydrocarbon chain. When you have different substituent groups like the bromo, chloro in the same hydrocarbon chain, or you have metal, ethyl, bromo, chloro on the same hydrocarbon chain, how do you name them? What rule guides that type of pattern? Okay. Now, when you have different substituent groups, the rule says arrange them in alphabetical order. For example, if chloro is in the hydrocarbon chain and bromo is in the same hydrocarbon chain, bromo is expected to come first because the word bromo started with B, letter B, while the word chloro started with letter C. So bromo will come first and will be considered first, even in terms of numbering the chain. You're going to use that bromo to number the carbon chain. Okay, so let us see. Supposing I have bromo at this point and I have chloro at this point. Supposing I have bromo at this point and I have chloro at this point. So how am I going to name this type of, how am I going to give a prefix to this compound? Now, bromo, since it's going to be the one I'm going to consider first, so numbering of the chain will begin with the carbon atom that is closer to where I have the bromo group, not the chloro group. So numbering will start from here. This is number 1, number 2, number 3, number 4. So I have 1, 2, 3, 4. So the bromo in position number 2 and the chloro in position number 3. Okay, so to arrange it now, we now have 2 bromo, you put comma, then 3 chloro. You see, in this case, they are separated. They are not fused together like we did previously. Okay, they are now separated because they are different substituent groups. So it's going to be 2 bromo, 3 chloro, and that's it. Now there's something I forgot when I was treating the other one, the one I said the same, the one I gave an example on having the same substituent group on the same hydrocarbon chain. Okay, so now what if you have a substituent group or substituent groups on the same carbon atom? On the same carbon atom. And let's look at this compound now. On the same carbon atom, having 2 chlorine atoms on the same carbon atom. You can see in this case you have chlorine up, chlorine down on the same carbon. So numbering can either start from here or here because the distance is equal from both ends. Okay? So if we are measuring the distance from here to here, it is 1 carbon atom gap. This is 1 carbon atom gap. So you have equal distance. You can say that they are equidistant from that point. Okay, so at this point now, if I start from here, so the 2 chlorine atoms, they are on the same carbon, number 2. So you repeat that number 2 times. 2 dichloro, yes. 2 dichloro. Okay. So we are done with rule number 3, which says when you have different substituent groups, arrange them in alphabetical order. Arrange them in alphabetical order. Now, having this at the back of your mind, I think we're good to go. I have exhausted all I need to tell you about prefixes and the rules that guide prefixes, okay, or substituent groups. Now, let us go to the roots. Without wasting much of your time, we have Greek roots. Like 1, a compound with 1 carbon atom is pronounced met, M-E-T-H, met. When you have 2, it's et. ETH. When you have 3, it is prop. 4 is bot. 5 is pent. 6 is hex. 7 is hex. 8 is oct. 9 is not, and so on and so forth. So when you count the number of carbon atoms in the longest chain, please mark this thing I said now. In the longest possible chain, because there are some structures, there are some structural compounds you see, having side branches, and if you're not careful, you might not be able to get the longest possible chain. So I'm going to give you an example of that so that you will understand what I'm trying to pass to you. Okay, now let's look at some structures and then be able to pick the longest chain that will form our root. Already we agreed that 1 carbon atom in a chain should be pronounced as met. So when you have 2, it should be pronounced as et. And then 3 should be pronounced as prop. And then 4 goes with part. So it's a rule that guides all organic compounds. So 5 we have pent. 6 is hex. 7 is et. 8 is oct, 9 is non, so 10 is dec. Okay, so let's stop at number 10. Let's stop at number 10. Okay, so I'll be back shortly. Welcome back. Now we're going to see I'm going to give you two typical examples on how to give the correct roots of giving hydrocarbon. Okay, so let's look at example A here and example B. So you can see that this is a straight chain isomer. The way you name a straight chain isomer is not the way you name a branched chain isomer. Now, in the straight chain isomer, that is easier compared to naming a branched chain isomer. Now, in the straight chain isomer, you have 1, 2, 3. You can just count the number of carbon atoms that is on the straight chain, so you can see it clearly. So 1, 2, 3, 4. So this is butane. That goes with butane, that box. So the ANA at the end of the root, that ANA is a suffix. Okay, remember I said we have 3 parts to the name of any given organic compound. We have the prefix, we have the root, and we have the suffix. So I've already explained prefixes or substituent groups. Then this one I'm explaining now is roots. Then the root sometimes, like in the case of alkanes now, the root can be fused with the suffix to give the full name of the hydrocarbon. For example, here is but, so when I add A and E, it becomes butane, okay? So now let's look at example 2. Now this is a branched chain isomer of a compound, okay? Now in this case now, to take the longest possible chain, remember, I don't only need to count on a straight course 1, 2, 3. I can also consider the branch 1, 2, 3, 1, 2, 3, 4. So you can see this is 1, 2, 3, 4. And if I also start from here, I will have 1, 2, 3, 4. So the rule says take the longest possible chain. So this is the longest possible chain of the compound. And having done that, you will see that there is a region, there is a space that is marked out and is not used, as the major or the main chain. There is a space that is marked out that is not used as the main or the major chain. So in this case now, I have 1, 2, 3, 4. So the root of this compound is butane. The other part that I marked out becomes a substituent group. It will now function as a prefix to the compound. So this is methyl group here. This is methyl, which is CH3. And it's attached to, so to number this chain, I think I need to start from this carbon number 1, 2, 3, 4. So this is 2-methyl butane. 2-methyl butane. That's the name of the compound. 2-methyl butane. So that is all. Now, always be careful when you have branched chains. Always be careful to take the longest possible chain as your roots. So I'm going to give more examples to buttress my point. I'll be back shortly. Right, welcome back. Now this one says, what is the Iupac nomenclature of the compound shown below? Now to name this compound, the first step to naming any organic compound, especially if it's alkanes, is to first of all find the roots. The root is the longest possible chain of carbon atoms in that hydrocarbon. So let us check. 1, 2, 3, 4 is a chain that's on a straight course. Starting from here, 1, 2, 3, 4, 5. It's also a chain starting from this end. Then I also have 1, 2, 3, 4, 5, 6. And I think 6 is the longest possible chain in this compound. So I already know that the root name will be hexane. I already know the root name will be hexane because 6 is the longest possible chain I have. Okay, now I will now map the region showing the major chain or the main chain in the compound. So see, I mapped it. So when I map it, you will see another part, this and that part that I may include in my chain. So this part that I may include in my chain becomes a substituent group, and that is methyl. So methyl is a substituent group that is attached to this carbon atom. And also you can see that there is chlorine also here. In the major chain, there is chlorine here attached to this carbon atom. So chloro and methyl are the two main substituent groups in this compound. So numbering now is very, very necessary because I need to know the position of these substituent groups on the hydrocarbon chain. And to do that, I need to consider chloro first. Remember what I said when I was explaining rules that guides prefixes or substituent groups. Okay, and I said the particular substituent group we're going to call first will be the one you will use to number your chain. So the proximity of the two ends, here is end 1 and here is end 2. So I will start numbering from here because of chlorine. So this is carbon number 1, number 2, number 3, number 4, number 5, number 6. So you can see that chloro is in position number 2. So the name goes as us 2 chloro. Then the methyl group is attached to carbon number 3. So I'm going to have 2 methyl, 2 chloro, 2 methyl, then I'll now add my root name, which is hexane, and you're done. So 2 chloro, 2 methyl hexane. That is the name of this compound. I believe that in this video you've learned a lot. If you have not subscribed to this channel, if you're a new person, you're watching me for the first time on this channel, please do well to subscribe to this channel. Click on the subscription button right below there, and then you're good to go. Alright, so in my next video, I will be handling the nomenclature of the alkanes and the alkynes. Thanks for watching. See you next.